Hello everyone and welcome to this tutorial. In this tutorial, we are going to be deploying an object classification model on the Arduino Nano 33 BLE Sense. We are going to be training the model on Google Teachable Machine to recognize some objects around the house, and then we are going to be deploying the model back to our Arduino board. One good thing about this tutorial is that we are not going to do a lot of coding, a lot of programming. We are going to be leveraging on Google Teachable Machine to train our model, and then on the same platform deploy the model to our Arduino board. If you want to learn more about how the coding works and how all those programming works, you can check my previous tutorial where I did everything from scratch. We trained the model on Google Colab, we converted the model from TensorFlow to TensorFlow Lite, and then we deploy it on our Arduino board. But in this case, you're going to be using the facilities of Google Teachable Machine to train the model, perfect the model, and then deploy it on our Arduino board. Talking about the hardware that we are going to be using, I'm going to be using Arduino Nano 33 BLE Sense board. This is going to be our main controller where we are going to be deploying our model, and importantly, we need a camera. So you can actually use any variant of camera that you have with you. But with me, I have OV7675. If you have 7670, it's going to work fine. And I'm going to be showing you how to connect the Arduino board to the camera. But one thing that I have with me here that I find really useful is the Tiny Machine Learning Shield. If you don't have this, you don't have to worry. I'm going to be showing you how to connect your Arduino board to your camera. But if you have this board, you can just plug straight in, plug your camera to this part directly, and then plug your Arduino board on the shield directly, and everything will be up and running in no time. But it's not actually a must. We can just look at how we can do the wiring between the Arduino board and the camera. Before we move into the tutorial proper, let's make sure we have all our hardware connection fully set up. And then I have the circuit connection for the Arduino Nano and the camera that we're going to be using. So whether you have Office 7670 or 7675, any of the two is still going to work perfectly. So I have the circuit connection. Just wire this as you can see on the screen. You can use a female to male jumper or female to female jumper based on your breadboard type or based on your pin layout. And after that, we're going to be connecting a push button also to the Arduino. So we're going to be using the push button as the shorter click. So whenever we click the push button, is going to take the images that we want. So connect this in this manner. Just connect one of the leg of the push button to A6 and the other end to ground. So whenever we press this push button, it's going to drive pin A6 to ground. So you can follow up this connection, and once you are done, you are ready to start the tutorial. So as I mentioned, my setup is different from the one I just showed. I have my board here, I have my camera, and I have a breakout board like a TinyML sheet. If you are able to have access to this board, it makes things a little bit easier. So what I'll just do is to slot this in. It's very easy to get this set up. So this is the USB point. Make sure it's pointing the same way. This is my USB. So this is going to come in here, and the camera will just go in here straight. Oh, that's a mistake. And the camera going in here. So there are few things I want to point out when using this board. So when I grabbed this board for the first time, I thought this button is the reset button, but it turns out that it's not a reset button. It's just a push button that's attached to the board. But one problem here is that the push button is connected to pin 13 of the Arduino, and we all know that pin 13 is connected to the built-in LED. So pin 13 is automatically wired to be an output pin. Though it's still possible for you to make it an input pin using external resistor, but because I don't want to go through that stress and it's very difficult to use pin 13 as input, so what I did was that I disconnected. If you can see from here, I was able to disconnect the wiring of this push button to pin 13, and I resoldered it at the back. So what I did there was just what is according to the circuit I just showed. So I'm now connecting the push button to A6 instead of original pin 13. So that's how I was able to bypass the issue with pin 13. It was very difficult for me to get it working. So I just have to resolder it to pin A6. And with that, I was able to get my board up and running. So one thing I discovered was that maybe due to the wiring of the camera, first time I firstly connect this to A2, it was giving a lot of issue. You can see there's some kind of soldering here. So I put it on A2 first. The camera wasn't responding the way it's supposed to respond. So when I switched it to A6, everything was working perfectly. So in case you want to try this out, just maybe put it on A6 or some other pins that might work. Some pins might not work. Just be prepared for that ahead of time. So that was I was able to have my circuit up and running. So let's just get straight into the programming and the data collection. Once you are done with the hardware connection, what you need to do now is to set up Google Teachable Machine and every software that you are going to be using. So to get started, just search for Google Teachable Machine. You can simply go to teachablemachine.google.com or just search for Google Teachable Machine on your web browser. You see that it's so much easy to get started with Google Teachable Machine compared to doing everything from scratch like we did in the previous tutorial. So I'll just click on the first link I'm seeing here, which is teachablemachine.withgoogle.com. There are different things that we're able to do on Google Teachable Machine, and you can feel free to read along to see what Teachable Machine can do for you, a lot of things that you can learn from there. So what I need to just get started, I'll click on get started. And yeah, from what you can see here, that we can do a lot of things with Google Teachable Machine. We can do image projects, we can build an audio project, and we can also do video projects that involves different posts. In this tutorial, we're going to look at how we can train an image recognition model. So what I need to do is to click on image projects, and from here under image project, you have two different types of images that we can do. We can select a standard image model and then embedded image model. What standard image model will do for us is if we want to deploy a model on a computer like Raspberry Pi, or even on a normal computer like a normal TensorFlow models. But what we need to select is the embedded image model, which will be optimized for our microcontroller like the Arduino Nano, the BLE Sense. So I've just select embedded image model, and here I'm presented with the interface, and everything that I need to do will be done in this particular web page. The first thing I need to do is to classify and give name to my objects. The first class is just like the images, the objects I used in the previous tutorial. The first class is cup. I use the cup, and then second class I'll just call it book. So we're going to be training our model to be able to recognize cup and book. There are three different ways you can send in data to Google Teachable Machine. If you are on embedded projects, you can use the webcam, you can use the upload, and then you can use device. If you want to use the webcam, it's going to be using your computer webcam. We don't want to use that in this case because we're not going to be testing our model via the webcam. We're going to deploy the model on our Arduino board. Also, I'm not going to be uploading. This doesn't really make much sense, since whenever I want to test our model, we have to use the camera from the Arduino Nano 3 BLE Sense. But if you take the images using the Arduino Nano, you can just upload them using this method. But what I'm going to be doing is to upload directly from my Arduino board. So to do that, I'm going to click on device, and then for me to set that up, I need to download three different things. I'm going to be downloading some source code, and also I'm going to be downloading a software. Now, that's some things I want to take note, I want to make mention of here now, is that naturally the way Google Teachable Machine is configured, things are not being updated, I would say, from maybe a very long time ago. So if you are going to follow along with what you have here, it's going to run into problem. You won't be able to upload your code to the Arduino board. So I'm going to be using my own code sample. I've done a lot of modifications to make sure everything is working perfectly. So I'm going to be downloading some things that I need to download, and then I'm going to be using my own code samples. So the first thing you need to download is the Arduino sketch. You can click here, and then it says changes may not be saved, leave, cancel. I'll just maybe right click and then open in a new tab, and then it asks me to download the TM uploader. So let me save this on my desktop for easy location like this. So I need to download another code. I'm going to show you how with that. I'll just right click and open a new tab. So I'll just download it normally now. Again, TM connector, I'm going to save it on my desktop. Now, before we open up these two source code, we need to grab a software online called the Processing IDE. And please pay close attention to this. I'll just search for Processing IDE. We can go to processing.org. For us to be able to locate things easily, I'll just search for Processing IDE and then download processing. Now, if you download the latest version, which is 4.3, as at now when I'm recording this tutorial, which is August of 2024, this is not going to work. So we need to download a previous version, which is 3.5.4. So for older versions, 3.5.4 and earlier, see our list of stable releases. I'll just click here. If you download the 4.0 version, things are not going to work. So again, version 3.5.4, this is the version that we need. I'm on 64 bits, so I'll click on Windows 64 bits, and then this asks us to download. So I already downloaded this, so I won't need to download it again. So once you download it, you install it. It's very straightforward to get started with, and then you'll be good to go. So I'll cancel this. So what you need to install is the Windows Processing IDE, which is 3.5.4. Take note, you have to install that particular version unless the 4.3 currently is not working as at August 2024. So once we are done with that, we are done with setting up our environment. We just need to go back into our computer now and then set up the source code. Now this is when things start getting interesting. As I mentioned, if you are going to follow along with the code we just downloaded and just follow the process or any of these, the official documentation online, things are not going to work perfectly fine. So what I'm going to do now is let me go to my downloaded files. So these are the two source code I downloaded, TM connector and then TM uploader. So if I unzip this, so this is an Arduino code. We are going to upload this code to our Arduino board, and then we are going to open the other code in the IDE that we downloaded, which is processing IDE. So extract to, okay, I'm going to extract this. Also, I'm going to extract TM connector. Close extract. Okay. Now, if you open up TM uploader, this is what you're going to be uploading to an Arduino board. If you open this, you can see it's an Arduino sketch. So one thing, I'll definitely just open this up and let me explain some of the things that is wrong here. And then I have the source code that I downloaded from Google Teachable Machine. If you check tmuploader.ino, what this code is basically doing is just taking some image frames and then sending it over to the serial. So the most important part of the code is this source file, which is imageprovider.cbp. So this is responsible for grabbing the image from the camera and then converting it to grayscale and then blurring it out to compress the image and then send it over to the serial. Now there are some problems that we're going to encounter if we are going to work with this code exactly, and I'm going to be explaining them. So the first part is where we define the capture width and capture height to be 320 by 240. If you are going to be training our model on this, by the time we are ready to deploy the model on the Arduino board, the file will be too big for the Arduino to process. So we are going to be having some linker issue as regarding can't move linker file backward and some error like that. I'm not going to be showing you how the error looks like. You can try to check this out, how the error will look like. So if you try to upload this is going to be uploaded. But when we reach the point of deploying the model on our Arduino board, we're going to run into error. The file will be too big for Arduino to process, so it won't even compile at all. So what we need to do is that we have to change this to 160 by 120. But the problem is that this image quality right now is QVGA, which the original model size is 320 by 240. You can't just write 160 here and then change this to 160 or change this to 120 directly. Though this is what is going to work, 160 and 120, but then we can't just change this directly because we're going to be altering the whole structure of this code. The structure of the code is meant to take in 320 by 240 image, and everything around this code is with the fact that we are taking in a 320 by 240 image pixel. But if you are going to change to 160 by 240, 160 by 120, which is what is going to work and will not overload Arduino, we need to change our model. So the model is going to become QVGA, and then we are going to be converting into UV type of image. So we're going to be restructuring the whole thing. One thing I can do is just maybe delete this and then paste in my own code. But I don't do that. I've modified the code. I've structured everything to working. I'll just open it up. So this is the working one. Oh no, this is the wrong one. Sorry. It's in documents TM uploader. And if I open this up, the names are still the same, but they're in different folder. But we are going to see the difference when we compare the two images side by side. The two codes side by side. So this is the modified version of the code, and let me open up the original version that I downloaded from. So this is what I downloaded. If you can check, just take note, the one by the left is the original code that come with Teachable Machine. If I come to TM uploader, everything here is still the same. Come to TM uploader, everything here is still the same. It's still going to work perfectly fine. But if you come to the original code and I go to image provider, you can see that the pixel, the capture width and capture height is 320 by 240. But if I come in here and scroll up, we see that the capture pixel is now 160 by 120. And you can see here, the conversion is from the original code, the conversion is from QQVGA to RGB 565. But if I come back to my modified code, the conversion is from QQVGA to UV 422. So this is what you're going to be working with so as to not overload our Arduino memory. If you can see here, most of the conversion that are happening here are different from what is happening on the right hand side. These are the conversions we need to convert from QVGA to RGB 565. But here we are converting from QQVGA to RGB to U422. You can check through. I'm going to be giving the link to this code in the description below, so you can check through and see how this works. So apart from that, every other thing is the same. If you come to image provider.h, we still have the same thing running. So I've just closed this up. I'll close the original code that I downloaded from online. I'll close this up and then I'm going to work with this. Now, before we proceed, let's also open up the second source code I've downloaded, which is the processing IDE source code. Again, this is the same. You don't have to alter this. Everything is the same. You just have to, everything works fine. So coming to desktop, come to which is TML. By now you should have downloaded the processing IDE 3.5.4. So again, let me open this and then you can just click on this to open it. So this is how processing 3.5.4 looks like. This is how the processing IDE looks like. Get started. And if you check through here, what this code is, what processing IDE is basically doing is that it's going to be grabbing our image from the Arduino Nano BLE Sense and be forwarding it over to the Teachable Machine, and be forwarding it over to Google Teachable Machine online. So if I go back to the website, so once I click on attempt to connect device, I'm going to be running the code of processing, and then it's going to be sending the image from the Arduino board to Google Teachable Machine. So I'll just come back to here, and then if you check through here, there's no more any need for any form of modification here. Everything is still correctly set. Our image camera weight is set 96 and camera height is also 96. Now that I have everything set up in my Arduino board, I'll just go ahead and plug in my Arduino board to my computer. But first, let me open up my camera feed so that we can see what is going on. So I'll just plug in this to my Arduino board, to my computer. And then I'm ready for upload. You can just click on upload to upload this. So once the uploading is done, let's go back to processing IDE. Let's click here and then just click on this run button. So it's going to display something that looks like a screen, and then we're going to be viewing our image from there. Once you open this up, on this port select, click on this and select COM6. And here we have a little, very blurry, not that perfect image of our environment. So if I try to move my hand over the camera, it's somehow really, really slow. But you know, it's a very low quality camera. So you shouldn't expect maybe something very better more than this. So I'm moving my hand over the camera now. Now let me bring up my camera field. So if I move my hand over the camera, it takes some time. It's dropping a lot of frames to reflect, but you can see that it's showing that I'm moving some form of movement of my hand over the camera. So it might take some time for it to become still. But once it's very still, so we can now take our images. Let me just get started with the training right away. So I'm going to be training first with a cup, just like I used in tutorial. And let me point this so you can see the image of the cup is coming up in the processing IDE. You can feel free to do a lot of modification to this for you to get better quality image. You can still do a lot of work on this to make sure you have a very good image. Let me raise the camera a little bit up. So I'll just go ahead and train my image model with this not so good quality picture. You can still try to modify this, try to position the camera very well for you to get a perfect angle of the picture. So once we are already receiving our stream from processing IDE, I'll go back to Teachable Machine and then click on attempt to connect device. Once you click here, it's saying connecting. So it's connected. If I go back to processing IDE now, you can see that it displays connected to Teachable Machine over here. So to start taking samples, I'll click on hold to record, and if I press hold, I just take 20 samples of cup. And don't forget, it's not only limited to 2 classes. You can use as many classes as you might want your model to be able to identify. So I'm done with 20 images of cup. I will change this now and then put in the book that I used also in the last tutorial. So now I have the book. So this is the book. it's still very blurry, just like the cup on. Again, this is the cup class, so I won't record it on the cup class. I've just come to book class, again, click on device. I don't need to download all this again. I've already done them when I was dealing with cup. So I'll just click on attempt to connect device again. And then it's connected. Just like if you come back again to processing, it says connected to TM, that's Teachable Machine. Again, I'll click on hold to record and take another 20 images of book. So with that, we are done collecting our data set. Now we have to train our model. Simply click on train embedded model. So clicking here. So it's going to train a model. While training the model, you shouldn't leave this page. I'll just stay here while the model is being trained. So we are done training the model. So I'll click on exit. Now the standard thing I need to make mention of here. Teachable machine accuracy is very low. Like it's somehow like the opposite case. So let's do a simple test now. Let's say you want to connect our device. Now we can test our model before we export it. So I'll click on attempt to connect device. And let's see what our prediction looks like based on our trained model. Let the camera picks the image clearly. You see the book is somehow recent. At least we get a very good accuracy here. So we can have that. You see that the book, this was the book that we trained it on, and it says 100%. And if I switch to the cup, let me switch over to the cup. One thing you have to take note of here is that your angle of, when you are taking data, the angle at which you take the data and how you place the camera must be similar or the same. So it's somehow good to just have the camera fixed in a position so that you won't have to be looking for the best angle that is different from how you take the data set. So this is the cup now. I'm still having book. So let me get it to look perfectly like how we take our data set. So you can see from, I was able to get the perfect angle. So it's in fact, yeah, you can see it says cup is 100% also. So this is how our model is working. I think this is somehow appreciable. At least we have 100% prediction for both cup and book. So now that we are sure that our model is working perfectly fine, I just click on export model. And then once you click on export model, you don't want to export your model as a TensorFlow JS because we're not going to be deploying this on a web browser. What you need to do is to click on TensorFlow Lite. And then after that, you click on download my model. No, you have to select TensorFlow for microcontroller. There are two options that you have here. You have floating point model and then a TensorFlow Lite model for microcontrollers. So select the TensorFlow Lite model and click on download my model. So it's going to convert the model in the cloud and then be able to download it on your computer. So once the conversion is done, it will be converted to a converted TinyML model. Again, I'm going to save this on my desktop. Click on save. And then I can now go to my desktop to view what is going on. Yeah, I have the converted model. What I'm going to do is to unzip this. So extract, I'm going to extract it again to desktop, close. And if I open it up, so this is what we have. So you can see we have a lot of files here that becomes our model. None of them is looking like a model per se, but when we open this up, we see that it's actually looking like a model. So these are Arduino code that we are going to be deploying so that we're able to perform inferencing on our Arduino board. So what we need to do is to open this up. Now, looking at all these files, which one can we actually say is our model? So I'm going to be saying this, the one that the person detects model data is our model. Though it's named person detects model data, I think that's due to how Teachable Machine perform the naming conversion. You can see here it's 3.2 megabytes. So this is our model file, and then we are going to be seeing how it looks like. It's going to look exactly like what we did in the previous tutorial. It's just a header file that contains a lot of hexadecimal numbers. As expected, this is going to tell us that it has to be in a folder. So just click on OK. It's going to create a folder and then put our Arduino code there. So let me just minimize this first while it opens up. And I also need to copy all of this and put them in the same folder that our Arduino sketch is on. I can cut this, enter this folder, and then paste it. So again, going back to my Arduino board to see whether it has opened up. Now this has opened up. If I minimize this, maximize this, you come to the first file that we have here, which is our Ino file. It's simply the tm template script.ino. We are no more doing, there's nothing much that's happening here. This is where our inference is being performed. Every of the TensorFlow Lite conversion is being done here. And then we are being able to run our model on this particular file and then see how it responds. So the most important part is the Arduino image provider.cpp. If you remember, we did something while we are training our dataset, which is changing from QVGA to QQVGA. The way this particular file is structured is also structured the same way our image uploader is structured. So you can see if I scroll down here, the captured width and height. The capture width and height are both 320 and 240. And we've agreed that this is not going to work on in this case because it's not going to upload on the Arduino. It's going to show error regarding can't link a file. Let me just run this to show you what the error looks like. So verify. Okay, sorry, I have to select the board. Arduino and BLE Sense at COM6. Again, click on verify. Oh yeah, this is the first error that you're going to get, which is a very strange error. I don't know why they don't pay attention to this. This is not supposed to be there at all. There's a variable that was used, which is cap data len, which was not declared in the code. I don't know why they made this mistake. But if you look at the previous code where we took the data set, same method was used, and then the variable was declared there. You can see it was declared here, which is const int cap data len equal to this. So I'll just copy it. I don't know why this was left omitted in the inferencing code. And then I'll copy it and paste it in here. I just have to come in here and paste it here. So even the space was left like that. So this was the mistake that, though this is not the error that we are both looking forward to, but then it's the first part of the error. I just want you to take note of everything in case you might need to submit a pull request to TensorFlow team to check this. Again, I'm going to just save this and then run this again while we anticipate the right error. Verify. So as you can see, this is the error I was referring to. See, it is cannot move location counter backward from this. So it's a linker problem. It's due to overloading of memory. And if you check our model file, this person detects.cpp, where we have our hexadecimal number. There are a lot of this file itself is 3.2 MB as we saw the other time. There are a lot of lines there going to we have like something like around 450,000 lines of code. Even though this is looking really big, this is not where the problem is coming from. The problem is coming from how we are taking in our image, which is the 320 by 240, which was what we corrected while taking our image. So this is what I wanted to show you guys on how the error, if you're going to work directly with what Teachable Machine gives you, you're going to run into this error. I've checked different ways of solving it. Seems there's no other way than trying to scale down and then restructure the code ourselves. What we did here is what we did while capturing the image. It's the same thing we're going to be doing here. The code is doing the same, basically the same thing. They are both image provider.cpp. So we're going to be changing this to a particular code that uses 160 by 120. And then we don't really need to do any much of work here. We just have to change this whole image processing part, the process image part, and change it to the one that takes in 160 by 120. So how I do that, we don't need to make any change. This is the first file we are dealing with. We don't need to make any change here. We're still dealing with everything here is still correct of 96 by 96. If you come in here, so you're going to make a change here. Arduino main.cpp, everything here is still correct. Image provider.cpp, everything here is still correct. Main function is still correct. Model setting, everything here is still correct. Cop and book, this is what we are going to be classifying. Model setting.h, everything here is still correct. So what you need to do is to change this from QVGA to QQVGA, and this is very easy for us to work with. I can just copy this whole thing and change it to what we have in the previous code. Let me take this a little bit down. This is where our processing is going on. So we don't need to change anything around get image. This is going to be the same as it is. So what we need to change basically is the processing where our code is converting from grayscale and is taking it to RGB 565. So this is where our adjustment has to start. We have to start adjusting from this side and up to the end of the for loop, which is exactly here. Now, if I go back to my previous code where grabbing data, you can see that it still look the same, just like what we have here. Still like exactly the same. Yeah. So what you need to do is to again just copy out this conversion up until the end of the for loop, and then we're going to replace that. Yeah. Take note where the changes are being made. So this is the beginning of the for loop. I'm using this color inside that, so I have to clean all this up until the end of the for loop. Just before return KTF Lite OK. So clean this up. So we've cleaned the area of conversion. So again, let me just clean this comment, and then you can paste in the new form of conversion, which is what we have here. So once I'm done with that, I just need one last thing to do, which is changing this from, let's have to change this to 160 and then change this also to 120. So once we are done with that, I still have to scroll down and do the proper conversion. You can see here from the get image, we are still dealing with QVGA and RGB565. So if I come back here, so we can see that we are dealing with QVGA and U422. So I'll just copy this. You can just carefully make all this correction so that your code is going to compile. So I'll do the copy and paste. Go on and save this. Let me check. I think everything should be done now. So these are just the corrections that you need to make. Once you're done with this, your code is going to compile, because instead of taking our image in 320 by 240, we are now taking in 160 by 120, which is also the same way we train our model. So there's not going to be any form of contradictions or conflict. We train our model using this image size, so we're also going to test our model using this image size again. So once you are done with this, you can just again compile. So sorry guys, there are some things I failed to mention here. Now there are two libraries that we are going to use in this code. Though they didn't come with the Teachable Machine code, the Teachable Machine model code. So that's the Arduino Office 767X, that's the camera library, and also the TensorFlow Lite library. You can simply go to download the Arduino camera library. You can just come to tools and then search for library in manage libraries, and you can easily search for 0v767. So you can just, I already have it installed here and it says remove. So, but the problem is that you can't download the TensorFlow Lite library. It has been removed due to, I don't know, I was reading in the forum about it. It was that it has been removed from the Arduino repository. So you need to download the TensorFlow Lite library externally, and it has to be 2.0 alpha. Take note, you have to use 2.0 alpha. I'm going to be dropping the link to the library in the description below. So if you want to download the library, just click on the link and then you'll be able to download the library, and then you can import it to your Arduino using whenever you download it, it's going to be a zip file. So to import it, just come to tools, manage library, and then I have to go back there. Tools should be in sketch. Okay, yeah, sketch, and include library. Just click on add.zip library, and then let me just quickly show you where mine is downloaded. Arduino libraries. You can see here we have Arduino TensorFlow Lite 2.0 alpha. So this is the library that you need to download. So once you click on here, after that, I'm going to be giving you a link to the description below, a link to the code, so a link to the library. So once you click here and then open, you'll be able to add the library to your Arduino IDE. So that's the two libraries that we need to grab that I failed to mention at the beginning of this tutorial. But with that, you are good to go. Another thing I want to mention is that this code takes a long time to compile. Though I'm going to pause it now and wait for it to compile, but usually takes a long time to compile. So just be prepared for that. And now you can see that the code successfully compiles. So after that, you can just click on upload to upload the code. And before I do that, I still in my processing IDE, I still have this open. So I'll just close this because the port is open, so it's not going to allow me to upload. I'll just close this. Yeah, after that, you can just click on upload. So once the code is done uploading, so we can now open the serial monitor to carry out our inferencing. So here we have the inferencing being done. It says, so it ranges basically from 127 to negative 127 to positive 127. So whatever it's I, will be showing positive 127, and whatever the percentage is low, it shows negative 127 or negative number close to that range. So let me open up my camera field and point this toward my book. So I'll just take this up and point it towards the book. You can see that from here, it's changing. So after when it got disrupted, we are seeing something around 44. But now I'm pointing it towards the book. So I'm having, let's this balance out. Again, what's important here is that you have to have the same angle as when you were taking data, so as to not cause much of difference between the data inputs. Here you can see I'm having my book to be 127, which is 100% in this case, like what we have when we're testing the model on Google Teachable Machine. And I have book to be negative 128, which is like 0%. So let me take this away and use the cup. So I hope I get the angle correctly. As you can see, it starts changing. Let's wait until this balances out. One thing I refuse to do here is to have a single angle, my camera fixed in a place. So but I think it's balanced now. So we have cup predicting 126, which is very high number, like 100%, and book predicting negative 120. Yeah, it returns back. But once you have this in best angle, your prediction is going to be correct, just like we have on Google Teachable Machine. Now let me just keep it at this point. I think this is a very good angle. Yeah, so you see cup is 127 and book is negative 128. So this is how we can do the prediction to use our Arduino BLE Sense to carry out image classification. Just try, if you want to learn the other approach, you can check the other tutorial where I train everything from scratch using Google Colab, convert it to TensorFlow and then change it to TensorFlow Lite before we deploy it to our Arduino board. So for me, I will say it's quite much easier to work with Google Teachable Machine, though once you do all the modifications that I did, everything's going to be working fine. It's usually not out of the box. There are a lot of issues, a lot of complaints, a lot of issues has been raised on Google Teachable Machine for embedded GitHub page. But I think I was able to solve the problem. And if you can follow along and try to copy the code I used in this tutorial, which I'm going to put the link in the tutorial, you should be good to go. You don't have to do everything from scratch like we did in the previous tutorial, where we need to train everything from Google Colab before importing into our Arduino board. So thanks so much, guys. Thanks so much. Don't forget, if you find this tutorial useful, to give me a like, a thumbs up, and please subscribe to the channel. It means a lot to me. And I'm going to see you guys in the next tutorial.